Okay, so we're going to have about a 20-minute fireside chat. You and I had a chat about a year ago.
We did.
Yeah, in Dubai. And what a difference a year makes. About a year ago, I think Bitcoin was around like $28,000, $30,000. And obviously all the other coins were around the same. And you were really just starting kind of your pivot into really embracing AI with ACP. And so I'll start out with a little background on Dominic. You and I have known each other for about 10 years. You remember like going to my home for parties in like 2014 in the early days of Coin Agenda. Last year, he was a keynote at one of the last Coin Agendas before we rebranded it Tokenized this year, and tokenizedconference.com. If anybody is in the United States or Puerto Rico the last quarter, we have one in Vegas during Money 2020 in end of October, and one in Puerto Rico for Puerto Rico Blockchain Week in the start of December. But you are, people say I'm an OG for getting in 2013. I mean, you actually were working in crypto in 1998. I mean, you were sort of embracing, the early cypherpunks with B-Money and Why Die. Tell me a little bit about that early vision that you sort of latched onto. And it took another 10 years for Satoshi to kind of do anything with that.
Truthfully, I was just trying to solve technical problems. So leading out to .com and in .com, I developed a thing called smart drives. And smart drives was a technology for sharing data and files online, and it did some clever stuff with compression. It did differential compression because back in the day, of course, we had dial-up modems. There was no broadband, and so it was a great challenge to transfer significant amounts of data. So there were two parts. There was meant to be like what would have been the world's, were it not for .com, probably one of the world's first cloud services, where you could store data online, and then there was a kind of enterprise product. And
that's true. 1998 was not only before crypto, it was before cloud.
That's right. It was before crypto and before cloud. And so I needed to secure data transmissions. So I started, looking at what cryptography was available, and I ended up using this guy Wei Dai's library. It was called Crypto++, and using a sort of Diffie-Hellman key exchange and rolling my own certificate system, actually. But it was all built on this Crypto++ library, which came from this guy, Wei Dai. Now, I had really no idea about the cypherpunk scene at the time, but on Wei Dai's Crypto++ library website page, there was a link to something called B-Money. So actually, I did, come across this stuff very early on, and I read B-Money, and I really had struggle to understand it. I could see there was some kind of unusual reasoning that I hadn't come across before. This was clearly something different, and I was intrigued by it. But I didn't really get too involved. I mean, at the time, I was just trying to use cryptography to solve my distributed computing problems. How to secure data when it's transmitted and so on. How to establish a remote link between two parties, and how to establish that the other side is the party that you think it is, and so on. So, but yeah, it was interesting because, it sort of left a kind of mental engram or something. I saw this B-Money paper, and then, later on I was sort of aware of Bitcoin, didn't get involved. I'm an entrepreneur. I built this online game called Fight My Monster, and it had some millions of users, and I was completely wrapped up in that. And at some point,
although when you read the white paper, you must have noticed that Wei Dai was mentioned 3-4 times.
Oh yeah, totally. Yeah, I mean, I think it was the first, the B-Money is the first, it was the first attempt at describing some kind of proof of work network that could be used to create, something like Bitcoin. And it's interesting that it goes right the way back, and the people were trying to solve these problems, even for 15 years before.
Well, David Shaw, I have a whole chapter in my book coming up, Bitcoin Supercycle, about the cypherpunks to show that the history of cryptography, goes back to the early 80s when cryptocurrency was invented, but they didn't have they didn't put all the pieces together. I mean,
That's right.
Sean basically was missing the hashing component. He basically, put a centralized custodian in the middle of peer-to-peer money. That didn't quite work. And then Wei Dai really described what it would be, but he didn't build it. But when Satoshi built it, that just changed everything. Just like what you're building now, I think has got, the ability to really change the way that decentralized AI works. So why don't we speed up, because we got 14 minutes left. Talk about sort of the vision then for how ICP came about, and how, as you developed it, you realized that it would be perfect for AI.
Yeah, so rolling back to the sort of, I switched full time into blockchain research sort of end of 2013. I was the first guy, working on repurposing what's known as classical Byzantine fault tolerant consensus for the blockchain setting, and proposing sharding schemes and things like that in 2014. And there was a paper called Pebble that was really mainly just circulated amongst insiders. But then I didn't launch Pebble. I got sort of sucked into the early Ethereum scene. And I think it was in 2014, there was this wonderful phrase, world computer. Mm-hmm. And I heard the phrase world computer and thought, wow, this is something we definitely need. And
that's a Metallics white paper, yes.
Well, no, it wasn't a white paper. I mean, it was a phrase actually that was just arose within the community. And my understanding, or at least, my view on what a world computer should be was very different to everybody else's. So, the early Ethereum scene, everyone was just very much in love with this idea that you can have a blockchain like Bitcoin, but now you can run a little bit of code on it, and you can do DeFi, and you can create new tokens through mechanisms that became standardized like ERC20, and you can run ICOs and things like that. And I thought that was great, but I saw blockchain in a more general way, which is that it hosts logic software that's tamper-proof, immune to cyber attack. It's guaranteed to run the logic. Blockchain guarantees you that it will run the logic that's written against the data that exists, and it's unstoppable. That software is always available. You can make the software logic and the data autonomous, so you can remove human control. You can compose smart contracts, and that's been very important in DeFi on Ethereum. So I looked at it and I thought, well, actually, a blockchain's a computation platform, and blockchains as computation platforms host a new kind of software. And, I've been coding for decades, more than 40 years. So I coded just about every different kind of system. So I recognized very quickly that smart contracts, it's a stupid name, smart contracts, by the way, came from some kind of paper from Nick Szabo.
Right.
It's an absolute curse. It's one of the biggest problems in the blockchain space that we called network resident code, or blockchain code that we call this smart contracts. It's a great shame. But I saw that this was a new kind of software, and it could be very important for humanity, because as we're seeing now, there's a cybersecurity meltdown, and it's impossible to make traditional software secure. Traditional backend software cannot be made secure. You can install a firewall, you can install anti-intrusion software, you can install anti-malware software. You will never make traditional software 100% secure. But here we can see that on a blockchain, we can have software that is immune to cyber attack, it's always available, it doesn't crash, and has all these other great properties. You can make it autonomous if you want, you can compose it. It's very easy to combine different smart contracts.
Make it self-executing.
Yeah, and so when I heard the word world computer, it made sense to me in a different way, which is that, eventually, since this new kind of software is superior, and it solves fundamental problems that are going to become more and more pressing, eventually, all back-end software and data, or the vast majority, will run on blockchain, because when you run on blockchain, you solve these fundamental issues. So then, I started thinking, well, how can we create a world computer that is, fast enough, efficient enough, has capabilities, so smart contracts can interact with HTTP and create user experiences. How can we do all of the things that are necessary in order to extend the internet with the blockchain, so people can build on the internet, and when they build on the internet, their web applications or whatever it is they're building, immune to cyber attack, never stop, and so on, and maybe can be built more productively too, and things like that. So that was a big job. And if you go back to the Wayback Machine, you can see the original DFINITY website in 2015. It was a DFINITY.io. And back then I talked about crypto ledgers that could scale out to host something like a search engine, a Gmail. And it was funny because, I probably at the time was the leading kind of proponent of, sort of advanced network math, the sort of pioneer of, repurposing, Byzantine fault-tolerant consensus for the blockchain setting, and also proposing things like advances to proof of work and different ways you can do things. And, I spent a lot of time promoting and propounding different technical approaches. But it was funny that people could see that they would work logically or mathematically, but it was very difficult to really take people from that mental place where, you have a blockchain, it's extremely slow, you have Bitcoin with one block every 10 minutes, an expectation, to take people from that place, and you have, Ethereum, which is, capable of at that time, like a handful of transactions a second, to take people from that place to where I believed we could go is extremely difficult. People were just skeptical, couldn't be convinced. So what I did was, started building out a team. And, one of the great things if you have a really ambitious project and you want to push the boundaries is that you will always attract the very most talented and brilliant people, because that's what they want to work on. They always want to work on something that changes the world. So, the early DFINITY team, like in 2016, as we got going, I was a co-founder and an incubator. Things like everything that people use today, like, WebAssembly.
Well, people don't understand the exponential. And when you were having the vision of being able to go from a block every 10 minutes or maybe, a few a minute to be able to do, tens of thousands a second, people can't fathom that because, again, society and technology innovation is all built on the exponential, and yet people in their understanding just can't see it. There's a great quote that comes from Ray Kurzweil, and he said that understanding the exponential understands realizing that if in a linear fashion you take 30 steps, you go 30 feet. Exponentially, you go from 1 to a billion.
Ray Kurzweil's a very clever guy. Whether the singularity will happen or not, it's another matter. But this point that he makes is very true. And I think, look, if you went back 100 years or maybe 200 years in England, somebody might live in a village. They might be a blacksmith. Their father was a blacksmith. Their grandfather was a blacksmith. And technology progressed very slowly. Maybe someone at some point, invented a pocket watch, or there was a better way of making wheels for a wagon. But, pretty much your life stayed the same and change was very slow. And we're in this kind of period where technology, does improve in some kind of exponential way. And it's always very important to look at the trajectory, not where you are, but the human brain is configured to look at the human brain.
It's hard to believe that ChatGPT is only 2 years old.
That's right. But I think the problem is that's the way the human brain is wired. The human brain is wired for a static environment, not for a rapidly changing environment. And that's why, if you went back to the early days of blockchain, people just couldn't imagine that you could go from Bitcoin to a blockchain that could, basically fulfill the role of all the clouds in the world. And you can see with the internet computer today, a lot of these early predictions are already coming true. There's been huge growth in compute. Certainly the case the markets don't recognize it, but at the moment it's processing about 1.5 million Ethereum equivalent transactions a second. And that's just the beginning. I think it'll eventually...
So that's really where the tie into AI comes in, because it was mentioned earlier today that you're really the only top blockchain that can effectively process at the level of an LLM.
That's right. So we've AI is very important to us because our mission is to have as much of the world's compute hosted on a blockchain as possible, and effectively extend the internet so people build on the internet rather than on traditional tech like clouds, and with that, and to get rid of the need for things like databases and so on. And so we started working to optimize the internet computer for AI, and AI runs much faster than it did when we did our first demo. And there are some important new changes coming to the network which should enable people to run, large language models as smart contracts. But I think that the last demo, or the facial recognition demo, or the image classification demo, I can't remember, but some of these operations are doing like 20 billion WASM instructions. So in order to be able to run AI as a smart contract on a blockchain, you need to make sure your network is extremely fast, efficient, scalable, and so on. And that's something we've been, working on for many years. So, I mean, since the probably end of 2017, Internet Computer Project has been by far the biggest R&D project in crypto in terms of, the number of people working on it. We employ a lot of PhD.
So the point of that massive scalability as well as the always-on aspect, I'm thinking of, today's advanced technologies that you would never even thought were possible 10 years ago. You go into an airport and it just looks at your face and it lets you through. But that system can break down and all of a sudden there's a waiting line. So if that was running on ICP, then all of a sudden it would be in there, it would let you in, and maybe you don't even need to talk to an agent because the agent has got AI empowerment, and any questions they want to ask you, they basically just ask you in real time, and
that's right.
They check it against the database of your responses in the past.
Yeah, so, I always like to look ahead and see what the problems are that we're going to be needing to solve, in the future. And look, I think in the future there are going to be AIs running on your phone, on the edge. There are going to be AIs running in the cloud, and there are going to be AIs running on the blockchain. And they're all going to have different advantages. Obviously, an AI on your phone is going to be very responsive. All the data stays in your phone, so you're not sharing your data with anybody. These massive models like Claude and GPT and Grok and so on, they're going to have their own advantages. They're going to be extremely powerful. And some models are going to run on the blockchain. So why would a model run on the blockchain? The answer is to gain the properties of smart contracts. So immunity from cyber attack. So one thing I think a lot of people are not thinking about is security. And increasingly, there was an article I shared on my Twitter just recently in Nature about how many researchers, for example, scientific researchers are running their own AI models locally now. And the reason they're doing it is because they can't upload all this confidential, for example, in the medical field, they can't upload all this confidential data to GPT, say. So, but where these AI models need to be shared, imagine a law firm, we know a few hundred partners, and they want to run Llama 3, and they want to have a vector database, and they want to stuff it with all their clients' communications, all the emails they've written to clients, all the legal filings for clients, maybe some relevant case law and, canonical.
Something you do not want to get hacked.
No, that's right. And look, I mean, can you imagine that you think, okay, we're going to run this Llama 3 on Amazon Web Services, and, we're going to orchestrate it and do all this stuff, and Johnny from IT can make sure it's secure. Good luck with that, right? Because Johnny from IT can't make it secure because it's not possible to fully secure traditional IT. And if the hacker gets in, guess what? You've just created a hot wallet for all of your clients' most sensitive data. And when it gets hacked, your law firm is toast. It's over. And many of your clients will have their lives ruined. So that's an example.
You also look, for example, when Twitter got hacked and they were able to go in and spoof the accounts, or not even spoof, go into the accounts. This is a 17-year-old got arrested who did this. He went in and took over Obama's account and said, I'm now giving you Ethereum if you end up contributing to my charity, and here's the address. And he did it for Bill Gates, Obama. It was amazing how many accounts he was able to get in.
Disastrous.
Because it's Web 2, right? And hundreds of thousands of dollars overnight. They found the guy, but I mean, that A would not have happened. It was on a secure blockchain. And B, I'm just thinking, what would happen? You gave a great example of the law firm that's going to be toast after its sensitive data honeypot gets leaked and it becomes effectively a hot wallet. But, let's say that you're taking over Grok and you then direct all these malicious things to go out there and create content with showing Kamala driving a race car into a cliff with her middle finger up and all this stuff. And it then gets uploaded into all these believable channels that are hacked. And Alice is like, whoa, what happened here? And so we already have enough, sort of AI fakes. Can you imagine on steroids what would happen if a hack happened?
Yeah, totally. And there are lots of reasons. I mean, in the case of the law firm, they might run their llama as a smart contract on the internet computer because they don't want to lose all this. They don't want to create a hot wallet for data, and they want to get guarantees. They're immune from cyber attack. They also might want a guarantee that, look, previously it took you, a lawyer 3 weeks to prepare for trial. Now it takes you three days to prepare for trial with the AI. But imagine like the lawyer waits until 3 days before trial, logs onto the AI, whoops-a-daisy, it's been encrypted by ransomware or the systems have crashed. Doom, right? Because it's not working. You've got to spend 3 weeks to prepare for trial, but you only got 3 days. But another, within crypto and like a DeFi focus, imagine a large language model that's acting as your own private smart wallet. You might speak to your large language model and say, hey, if wrap Bitcoin hits 100,000, swap half for USDC or something. You can only do that if that large language model is a smart contract, like it's an on-chain wallet effectively that you control. Otherwise, you're trusting whoever's running the large language model because, it might not be the large language model that's directing your sales and transfers of crypto. So even within the realm of crypto, but I think it's very important for, for blockchain to look beyond crypto. Like, how can we solve the fundamental problems of humanity? And look, I mean, there's a cybersecurity meltdown. Governments all over the world, corporations all over the world are desperate for solutions to the cybersecurity problem. AI, I think, is going to make that more acute, both by enabling hackers and by giving people this conundrum, like, do you upload your sensitive data to OpenAI and Anthropic and so on and trust them? Or do you try and run your own AI model, but, how are you going to secure it? These are really big things. The other one, of course, with AI is data. And speaking to a project earlier and doing something, really cool where they're running AI agents on phones and pulling in, they've got connectors so they can pull in data from, all the different sources like Calendar and Gmail and Uber and so on, and they can orchestrate things for you. But, the question is you're aggregating this data, you've got a vector database, where does that live? And in the future, people are going to aggregate data and they're going to want ownership of their own data. Well, where does it go then? Well, on the internet computer, for example, you're guaranteed that it doesn't get hacked. You're guaranteed that you own it. Nobody else has access. You're guaranteed that it's always available. And data, of course, is the lifeblood of AI. You can't have a personalized, you can't have a personalized AI that does things for you if it's not got access to your data. So then you get back to this question of where does the vector database go, which contains all your personal data? And again, blockchain can play an immense role. So I think it's certainly true that, yes, there's a lot of projects out there that are selling that they're going to create a...
So I know we're out of time, but I want to ask one last important question, which is, what do you see in the next 3 to 5 years, 3 really large industry models that are going to be used by, millions of people that can come from this technology?
I think it's very difficult to predict, and I'll tell you why. So the capability of AI is improving very rapidly, but it's unclear whether, for example, it's going to continue improving at the same pace, at an exponential pace, or, for example, we're going to hit the limits of the transformer model, and then there's going to be a delay of a few years while we have to work our way around it. So I'll give you, currently, the actual workings of current AI are pretty simple. And we've got these emergent effects and these kind of basic reasoning abilities because we're just shoving all these word embeddings into the huge numbers of parameters with vast training operations. And of course, words actually carry concepts. So although the AI isn't actually directly processing concepts, it kind of indirectly is because words and word embeddings carry concepts. But I think it's, first of all, there are new kinds of models being created. There's one called Liquid AI that's being created as a spin out from MIT. And it's able to do inference for many things 1,000 times faster. And you can train it with 20x less effort.
That would make a difference in, say, medical diagnosis.
Totally. And look, imagine if you can do inference 1,000 times faster, you can run a much more powerful model on your phone. And they basically went back to first principles and they created this AI model by starting with a worm, actually a nematode worm from the sea, turns out the nematode worm has only 270 neurons, and it was possible to perfectly model the nematode worm's brain. And when they did that, they found out that the activation functions inside the neurons are very different. It was like something approximating to a differential equation. And that, whereas transformer models afford only propagation, that there were loops in the layers. And so, they've got these really interesting new properties by creating a completely new kind of AI model from first principles. So that shows you how quickly things can change, and potentially we can get these huge leaps. Huawei, I know, is in France, and there's this guy, a mathematician called Grothendieck, and he created topos theory, which created mathematical ways of generalizing thought and connecting different kinds of reasoning in different fields. And Huawei have hired a bunch of the world's top mathematicians, and they're working on how to repurpose that for AI. And if those kind of activities succeed, and of course the timeline's the only real uncertainty. Of course, these things will begin to succeed. Then AI's abilities can really increase exponentially. But on the other hand, for all we know, that could take years to do that, and often projects do take much longer to bring to production than you might want. Look at the internet computer; it's years and years of R&D effort. And so it might be there's a transformers reach their limit because transformers currently are being made smarter not by there's some better AI design, but it's also just by scaling the underlying mechanisms, right, with more and more GPUs and things. So it might be that we hit some kind of limit there, in terms of how many different GPUs you can combine and access to the power to run them and so on. And then there's a delay, and then but long term, AI is going to get so much smarter than it is now. We're just at the beginning, really, of this ramp up in the power of AI. So, a lot of these things, these questions, the next questions are just because AI is powerful, that's not all good. When you're using GPT, you're using a locked down version, but researchers are given access to an unlocked version of GPT, and they found that they could use GPT to hack a vast number of online systems and websites. So things like cybersecurity are going to get much, much worse before they get better, because hackers are going to be augmented by AIs that can even do things like find zero-day exploits by analyzing source code and things like that. So, there's a completely new environment that's emerging very rapidly, and I think blockchain. There are a lot of people in chain. There's a lot of blockchain projects that are really promoting tokens for AI. For me, someone is a kind of theoretician. That there's nothing. I'm not against tokens for AI, but I think blockchain, crypto really needs to be thinking about how can we, support this generational change in technology at a very fundamental level, and that involves things like preventing AIs that people are running in the cloud, or an internet computer like a blockchain cloud, becoming hot wallets for data, so that. And this is important because, if that's not possible, we're going to end up in the same place where everyone just has to trust big tech, right? Because we can't look after our own data, so we're just going to trust big tech to do it for us. And that'll be a bad place. We'll be in a much better world if people are able to run their own AIs, and there's lots of different kinds of AI model competing against each other. So, the markets drive and competition drives faster advancement of the technology. But that requires, support in areas like cybersecurity and resilience and composability, and all these things that blockchain can solve. So I think blockchain can play a really, really important role in the future of tech generally.
Self-defined and self-directed. So just as Bitcoin was be your own bank, it's be your own LLM.
Yeah, totally. And sometimes your LLM will run on your phone, and in that case, you don't need blockchain. Except maybe you want to use blockchain.
You could. Well, you could access it from the phone.
Well, so you look, if you keep your vector database with all your personal information on your phone, and you lose your phone, you've lost all your data, right? So you probably want to copy it onto the blockchain. Yeah. So you probably want to use blockchain as your backup for your vector database. And then, by the way, of course, if you get a new device, immediately you can just pull the vector database off the blockchain and boom, you're up and running again. So there are so many ways that blockchain can support this huge transition, and it goes so much further than than tokens. Like tokens is like not really the main way at all. I know that in this industry we tend to get really excited about tokens, but tokens aren't really how blockchain is gonna support AI. It's all gonna be about security, resilience, autonomy. For example, if you run an AI as a smart contract, you can put it under the control of a DAO, just like Uniswap runs under the control of a DAO, right? Uniswap stamps out new versions. The Uniswap DAO stamps out new versions. You can do that with an AI, and you can have a DAO that controls an AI and updates to the weights, right? Go through the
People get
Dominic,
tokens because of the
Michael,
price go up. But yes, I know we're over there.
I want to thank you guys for your time. I want to comment that maybe what you've alluded to is about trusting ICP. And from that premise, it'll all work.
hopefully.
Thank you. Thank you. Everybody, give him a round of applause, please.